Assalamu alaikum. Hello everyone. Today I am going to discuss with you some theorems from statics in mechanics. These theorems will need to solve the problems of chapter 8.2, which is the second chapter of static in mechanics. Here I told you in my previous video that I choose these problems from the HSC high secondary books of Bangladeshi students. I hope this will help you to understand the topic more easily. Now here the first theorem is if three coplanar forces acting at a point can be represented in magnitude and direction by the three sides of a triangle taken in the same order, then the forces are in equilibrium. Here before starting the explanation, first I should tell you what is equilibrium forces. Actually, equilibrium force is the force required to keep a system at rest or in uniform motion by balancing all acting forces. It ensures that the net force on object is zero. When two or three forces are in balance and the net force becomes zero, then they are in they can be called equilibrium force. And concurrent forces intersect at a single point in the plane but may have different direction. Concurrent forces may have different direction, but at a single point they are acting in the plane. Okay, and also coplanar forces we need here. In coplanar forces refer to forces that lie and act in the same plane. Now our theorem was now the proof of this theorem here I am going to discuss with you. Okay, here three forces P, Q R act at the point O along OX, OY, OZ respectively, such that they can be represented by three sides BCCA and AB of the triangle ABC. In triangle ABC, by applying vector addition, we can write AB plus BC is equal to AC. We can convert this AC into minus CA, so AB plus BC plus C is equal to 0. So therefore the forces will remain in equilibrium. Now next, here Lami's theorem of equilibrium forces. If three coplanar forces acting at a point along the different lines be in equilibrium, then the magnitude of each force is proportional to the sine of the angle between the other two forces. Let three coplanar forces P, Q, R are acting at the point O along OX, OY, OZ respectively, then they are in equilibrium, and we have to prove that P by sine alpha, Q by sine beta, R by sine gamma, where Q, the angle between Q and R is alpha, R and P is beta, and P and Q, the angle is gamma. Now since P, Q, R forces are in equilibrium, their proportion resultant is 0. P plus Q plus R is 0. By cross multiplying this vector with these three vectors, we get R cross P plus R cross Q and plus R cross R is equal to 0. And here then R cross R is 0, so R cross P and R, when we change R cross Q into Q cross R, we have to bring a minus sign here, so R cross P is equal to Q cross R. Here we get RP sine beta, since the angle between P and R is beta, and this is a unit vector. We know this formula from the vector, which is cross multiplication formula. So here we get a p sine beta and here q sine alpha. So p by sine alpha is equal to q by sine beta. Similarly, we can show that q by sine beta is equal to r by sine gamma. So p by sine alpha is equal to q by sine beta is equal to r by sine gamma. Proved. Next, converse of the theorem of Lamis theorem. We have to prove the previous theorem in reverse way. If three coplanar forces acting at a point be such that the magnitude of each force is proportional to the sine of the angle between the other two, and no force is equal to the resultant of other two, then the forces are in equilibrium. That means PQ or three forces are acting at a point O along OX, OY, OZ respectively, and also P by sine alpha, Q by sine beta, and R by sine gamma are equal, where YOZ is equal to alpha and ZOX is equal to beta and XOY is equal to gamma. So given P by sine alpha and Q by sine beta are equal, so P sine beta is and Q sine alpha are equal, we have to multiply R on both sides. So RP sine beta and QR sine alpha are equal. So we can write, where this is a unit vector, so we can write R cross P is equal to Q cross R. So R cross P is equal to minus R cross Q. So R cross P plus R cross Q is equal to 0. We can bring R cross R here, and if we take common R vector, then we get P plus Q plus R in between the brackets. So P plus Q plus R is equal to 0, which implies that these three vectors are in equilibrium. I hope this lecture will help you to understand the theorem of 8.2 in statics more better. And please, if you have any problem in any specific theorem or any specific problem, please suggest me, comment in my YouTube channel, and please support my YouTube channel, and subscribe my channel. Thank you everyone. Assalamu alaikum.